So what is a series? A series is the sum of the terms of a sequence. So instead of us just finding the pattern and writing the next term or terms, we are adding them all up. So a series is the sum of them. So the way we do the sum of an arithmetic or geometric series, we use this symbol called summation. Okay, this Greek letter sigma, also known as sigma notation. And then on the bottom, you're going to write n equals, and the number of the first term you are adding, not the value. So that means if I want the first 10 terms, the first term that I'm adding is number 1, so n equals 1. If I want the third term to the 10th term, then the first term I want is the third one. And then on top, I'm going to put the number of the last term you're adding. So if I want the first 10, I'm going to put a 1 here and a 10 here. You're not putting the values of those terms, and that's huge. And then after the summation comes the explicit formulas that we talked about. And again, this is also called sigma notation. And sigma is the Greek word for this symbol. So in truth, you've already worked extensively with series in a previous lesson, almost any time you evaluate a summation problem. And we changed the order, so summation problems are what we're doing next lesson. So you have not worked extensively. We're just beginning this work. So, given the arithmetic sequence defined by a sub 1 equals negative 2 and a sub n equals a sub n minus 1 plus 5. So again, adding means arithmetic, so this is your common difference. Which of the following is the value of s sub 5, so that means the sum of the first 5, when it equals the summation from 1 to 5 of a sub I? So this means that I start with the number 1 and put it in here. So a 1. Great. So I want from the first to the 5th term. So then I'm going to go to the 2nd term, the 3rd term, the 4th term, and the 5th term. And the E and the S means I'm summing. So I'm adding these terms up. So what is the first term? Negative 2. Plus, what is the second term? Well, the second term I have to add 5. So negative 2 plus 5 is 3. Then I have to add 5. 8. Then I have to add 5. And then I have to add 5. Now, I need to add all those up. So, pause it and add them up. And you should have gotten the answer of choice 2. The sum is 40. So, the sum of the first 5 terms from 1 to 5, we found them and added them up, and we got 40. All right. So now exercise 2. So given a geometric series defined by the recursive formula a sub 1 equals 3 and a sub n equals a sub n minus 1 times 2, so this is geometric, this is our r, so we're multiplying. Which of the following is the value of sum of the first 5 terms? So it's written again, so we go from 1 to 5, and we substitute in for I. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. We sum them because that's what that definition tells us. So the first term is 3, plus the second term, you multiply by 2. The third term, multiply by 2. Fourth term, multiply by 2. Fifth term, multiply by 2. Go ahead and add them up. And your answer should be choice 3, 93. So they're not going to give you this definition here. They're just going to tell you to find the sum of the first 5. You have to know that you find the 5 terms, if they're not given to you, and you add them up. It's not always that easy, of course. So in exercise 3, find the sum of each arithmetic series shown below. Notice, arithmetic means we are adding. So what are you adding? Well, what am I adding to 5 to make 8? What am I adding to 11 or 8? Adding to 8 to make 11. So you should have said I'm adding 3. So that means my common difference, D, is 3. Okay. I have to find the sum of these. I don't even know how many are in the sequence. Could I list them all out and then add them all up? Of course. But my job is to teach you the math behind it. So the sum, we're going to write the summation symbol. We want these terms. Well, which term is 5? It's the first one. What term is 8? The second. What term is 11? The third. What term is 77? I don't know yet. So what I do know is I want from the first term to the I don't know term. So I know that this is the first term. I don't know what number yet goes up here. I got to figure that out in a minute. After this is my explicit formula. So for arithmetic, it's a sub 1 plus my common difference times n minus 1. So what's my first term? 5 plus, what's my common difference? 3 times n minus 1. I can't do 5 plus 3 because 3 is being multiplied. So don't ever do that. So now, how am I going to find out what term number 77 is? Well, I know the value. Well, the value of some term goes here. So I know, I'm just going to keep working up. So 77 is the first term plus the common difference of 3 and number of times minus 1. I don't know what number times. Remember, it's 1 less. Well, I don't know what number term this is. So I'm going to solve this equation. So 77 equals 5 plus 3n minus 3. All I did was distribute. I'm going to combine like terms. So 77 equals 3n plus 2. Subtract 2. 75 equals 3n. Divide by 3. That's the world's worst 3. So n equals 25. So that means there are 25 terms in this sequence. So I'm going to put a 25 up there. That's how I get this number. I have to set this equal to my explicit formula. That's how you find a specific term number. You also can use it in your summation to figure it out. Now here's the cool part. You're going to grab your calculator. You don't actually have to do this. Your calculator will. So grab your calculator. So you want to be on a calculator page, and the summation button is next to the number 9. So hit that template next to the number 9. And it's where we went for our piecewise. It's where we went for our absolute value. It's where we could go for our fraction and our exponent and our radical and our root number and our e and our log. Wow. Now we're going to learn that there is the summation right here. Cool. So click on it. It gives it to you. You just have to fill in the boxes. So n equals 1. My formula was 5 plus 3 times n minus 1. And on top I have the 25th term. So I want the sum from the first term to the 25th term. And here's my pattern. So hit enter. So the sum of those terms is 1025. So we go back to our paper, and this equals 1025. So the sum from 5 to 77 is 25 terms, and they add up to 1025. So you know me, that was arithmetic. We're adding. Now we need an example with geometric. So again, find the value, and we're summing them. So notice how now with a series, there's not commas, there's plus signs or minus signs. So to find the value of a series, I have to sum it. Well, 6 is the first term, second term, third term, I don't know term. So I'm going to have to do that deal again. So I want from n equals the first term to the I don't know what term. I'm going to write my formula here. So my explicit formula is a sub n equals a sub 1 times r raised to the n minus 1. So my first term is 6 times, what is my r? What am I multiplying these by? Hopefully you said 2. And it's raised to the n minus 1. Now I have to find out what term 768 is. I know the value, so 768 goes here for this whole thing. So 768 equals a sub 1 was 6 times 2 to the n minus 1. Well, Mrs. Ferletti, that looks just like what we did in our last unit. Correct. This is an exponential equation. So I have to get this in Ben form. So I'm going to divide by 6 first. So this should just look like an exponential equation. I have to get it into Ben form. So I have to first divide by 6. So I get 128 equals 2 to the n minus 1. So you have choices here. You can use, this is Ben form, so you can use logs, or you could use like bases. It will always, in this type of a question, be like bases. So that's what I prefer. So 2 to what power is 128? And you should be saying 2 to the 7th. So once my bases are equal, 7 equals n minus 1. So 8 equals n. So I'm looking for the first 8 terms. So I'm going to take out my calculator again. I'm going to get the summation button. So go to next to the number 9 to get the template. Click. N equals 1 on the bottom. My explicit formula is 6 parentheses 2. Get out of the parenthesis. Caret button. N minus 1. And I'm going the first 8 terms. And you guys, we're multiplying. So the sum of the terms when you're multiplying is going to be big. So 1,530. Because I only went the first 8 terms. If I did the same thing I did in the arithmetic one, the first 25 terms, this number would be gigantic. Okay? So 1530. So this equals 1,530. So series questions, finding the sum of a series takes a lot of concepts in one. So in exercise 5, now we have 2 word problems. Kirk has set up a college savings account for his son Maxwell. If Kirk deposits $100 per month in his account, increasing the amount he deposits by 10 per month. So if I'm increasing the amount I'm adding, then how much will be in the account after 10 years? So let's be careful here. So we want the sum. And we want the first month to how many months? Well, 10 years is how many months? 120 months. So we want from the first month to the 120 month. We started with $100. So that's our A sub 1 plus. We're adding, so it was plus. Our common difference is $10 per month. So 10 times n minus 1. Make sure you double close that. Grab your calculator. Let's get our summation again. Fill it in. N equals 1. We have $100 and we're adding to it $10 per month. For 10 years, which is 120 months. So we will have $83,400 at the end of 10 years, and that's without interest. So $83,400 at the end of 10 years. Not too shabby. And Maria. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. Maria would like to determine how much money is in her account after she has made her $500 deposit at the end of 10 years. So first they're asking us to determine what A sub t is. So A sub t equals, well, what did we start with? What was our initial amount? 500. We added to it how much? Well, we have, it earns 5% interest compounded. So 1 plus 5%, and this should be, jogging your memory from last unit. T years. Well, we don't know how many years, so there's our t. So this is an exponential equation, which is also us multiplying, so it's geometric. So write a geometric sum representing the amount of money in Maria's account after 10 years. So we have sum n equals 1 to 10 of 500 times 1 plus 5% raised to the t. Doesn't even ask us to find it, does it? Oh, and evaluate the sum. Yes, it does. All right, so get your summation. So n equals 1. We started with $500. We're going to multiply by 1 plus 5, and don't forget your percent symbol, raised to the n for 10 years. Whew. So to get this fraction into a decimal, hit Control Enter. So $6,603.39 is how much we have after 10 years. Now, I made a mistake in here. This should have been an N because these have to match. Okay? If I was going to use the T from here, this would have to be a T. But most of the time I use N or X. That's the most common. So these have to match. Otherwise it won't work. All right? So if we started with $500 and we only make 5% interest, we're not adding any money in, then we end up with $6,603.39. Good luck!